All right, so let's see just a review of what you did in class today for the test tomorrow. So this first one, it says, which of the following is closest to the sample deviation of the data shown below? So we got to put everything into the calculator into L1. Okay, so first thing I'm gonna do is I'm gonna clear, and I may have something in L1 and L2, so I'm gonna do an L1, commas above the 7 key, and I'm gonna do the L2, which is the 2 key, second L2, and in my calculator, that means done. Now I can go stat, and I can go edit, and you can see all my lists are clear. So I'm gonna put this data in 31, 18, 30, 31, 18, 19, 33, 34, 20, 37, 15, and 28, okay? I always just count, so there's 12 datas, 12 datas. Then you're gonna go and make sure I have to make sure I enter the last one. So I would enter the last one on your TI-84 too. So I'm gonna go to VARs, and this is a VARs 1. So we're gonna go over the calculate, we're gonna go stat, and then I'm gonna go over to calculate, and it's in VARs 1. The sample standard deviation is the SX, right? So SX is equal to 7.61 something. So the one here is 7.6 if you round it. So this is 4. This is which of the following statistical measure represents the average distance a data point is from the mean. Okay, so remember, mean has to do with standard deviation. Median has to do with the quartiles and the interquartile range. So this is a standard deviation. That is actually the definition of standard deviation. The average distance a data point is from the mean. All right, the next one is they want the interval below which contain all sets of values of the data. Okay, so you take 25, all sets of the data. You gotta remember, 2 standard deviations is 95%. That's 2 standard deviations. 1 standard deviation is 67%, right? That's 1 standard deviation. So if you're looking for typical, you would say 67. If you're looking for most, 95% of the data is most of the data. So I'm going to take 25 and I'm going to subtract 2 times 4.3. I'm going to take 25 and add 2 times 4.3. And you get 17.2. And you get 34.4, which is choice number 2. All right, so this one, group A is more symmetrical than B. Yes, it is, because it doesn't have these little things here, right? So B is definitely symmetrical about the middle. The range of group A is, than it is for group B is greater. Yes, because you have these numbers out here, right? So that's true. And we're looking for what is not true. Group B has more variation in group A since its mean is higher. Well, the mean is not an indication of variation. It's just the average, all the numbers added up and divided by the number of datas. So 3 is not a valid statement of that data. All right, so explain why this is an example of statistical question. Well, for it to be a statistical question, you have to have variation. So this one has there is variation, the number of chips vary in each cookie, right? Right, as long as you have a data that varies, it means they have different values, then you can use statistical analysis in your questions. All right, so here we go. The next one is find each of the following measures. So now, again, we got to put this in L1, right? So, right, we got to put this in L1. So I'm going to, first thing I'm going to do is go stat, and I'm going to clear list, and I'm going to put in second L1. And I don't have, I know the other one is cleared because I cleared it for the first question. And then I'm going to go stat, edit, and I'm going to put these in. There's a 2. There are 2 9s. There are 2 10s. There's 1, 2, 3, 4 11s. 1, 2, 3, 4 11s. There are 3 12s. 1, 2, 3. There are 1, 2, 3, 4, 5 13s. Right? 1, 2, 3, 4, 5 13s. There's 1, 2, 3, 4 14s. 1, 2, 3, 4 13s. There are 2 15s. 1, 2. And there is 1, 2 17s. So a 17 and a 17. Okay, so we have all the data in. Now we can go back to stat. And everything that we're looking for here is in 1 vars, right? So we're going to go over to calculate. And we're going to calculate 1 vars, right? It tells you which list. You're going to use that list. Let's look at some of the data, right? They want to know the mean. Well, the mean is 12.2. That's the one with the little bar over it, X bar. The median, we have to scroll down for the median, is 13. The sample deviation, I have to go back up a little, right? S of X is 3.0 to the nearest 10th. The first quartile is 11, and the third quartile is 14. Okay, so now we can construct a dot plot. A box plot. So the first thing you need is the minimum value. The minimum value is 2, so you put a little line there. When you go from left to right, the next thing you come to is the first quartile, which is at 11. So you put a little bigger line there. The next one you want to graph is the median, which is 13. Right, so I have 11, 12, 13. And the third quartile is 14. So that's the box in the box plot. Right, and then you could extend this here. And the maximum value is 17. So 17, we'll put a little line there. And that's what your box plot should look, right? It's minimum value, first quartile, minimum value, first quartile, the median, the third quartile, and the maximum value. All right, it says construct an interval of values that are within 1 standard deviation. So we take the standard, we take the mean, 22.2. I'm sorry, it's 12.2. 12.2. And we're going to add the standard deviation, which is 3. And 12.2 minus the standard deviation. So this is 15.2 to 9.2, right? We only need one here, it says. All right, so we want to know how many datas are within that range. So you go up to your chart up here, and you go 9.2 is about here, right? And 15.2 is about here. So all those within that box are data. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. There are 20 values. All right, and then the last one is a question. It says, since the data contains an outlier, which means it's skewed to the left, right, because the outlier is smaller, should you use the mean, right? And we discussed this, right? This value, these 20 values, make it 80% of the data, which isn't a good variation. You want it to be 67%. So when you have a skewed, it makes it go to one side. So that wouldn't be. So you would use the median and interquartile. It doesn't X for that part, but you would use the median, not the mean. The median and interquartile because the mean is skewed left. Right, so it wouldn't be in the middle of the data, it would be to the left of the data, okay? And then finally, we have this question here where we need to find the regression, linear regression, right? And I'm gonna give you the formula tomorrow, right? So we find that in linear regression, we'll find it when we go to calc, right? We're going to use calc, not vars, not one vars this time. So the first thing we have to do is we have to make sure we clear the L1 because that has data in it, right? Since I'm using both, I'm going to clear both of them, right? So I'm going to do 4. I'm going to do second L1, the commas above the 7, second L2, hit enter. Yours will say done. Mine says box because they're empty. That's empty sets and set notation, just in case we're interested. And then I'm going to go back to stat, and I'm going to go to edit, and I'm going to put these numbers in: 29, 18, 22, 26, 14, 4, 8, 12, 17, 21, 20. And like earlier in third period when I did one, I didn't have enough datas for both sides, right? That says 11 datas. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 datas. So we're all set, right? So now I'm going to go over to L2. I'm going to put in 4, 24, 11, 13, 20 goes with 14, 4 goes with 38, 8 goes with 25, 12 goes with 30, 17 goes with 32, 21 goes with 27, and 20 goes with 10, okay? So we have 2 columns, we have them all filled in. Like I said, the last one I always return, because especially with this calculator, it doesn't work. Then we're gonna go back to stat. We're gonna go to calc, move it over to calc. But we're not gonna use vars 1, we're gonna use the one that looks like the equation there, the ax plus b, that's the equation over here. So we're gonna go 4, and this is just telling us the x's are L1, the y's are L2. Hit enter, and it'll give us these values that we need. Okay? Now it says calculate round value A and B to the nearest hundred, so we need 2 decimal places. So I'm going to say y is equal to negative 1.13 x plus 40.92 to 2 decimal places. Now it says give an interpretation of the x-intercept. Right, the x-intercept is this number here. It happens when x is 0, right? So we can say the x, so we're going to state this, right? And x is always 0 when we're talking about the y-intercept. So we could say when the fat is 0 grams, right? The bars, right, the nutrition bars will have 40.92, whoops, 40.92 grams of starch. Okay, so good luck tomorrow.